Welcome to the Tailings Podcast, where we dive deep into the world of tailings management and all things geotechnical engineering.
It's fascinating stuff.
It is fascinating.
Yeah.
And this podcast, it's the brainchild of Mohammed Sabi, who's been working really hard behind the scenes to bring you the most interesting research and insightful conversations.
He's really passionate about it.
Yeah, and I think that's what makes the show great.
Absolutely.
I'm Ethan Cole, and I'll be your guide through all this complex and often overlooked stuff. And with me, I have the brilliant Olivia Wells, our resident expert, who can break down even the toughest technical concepts so that everyone can understand.
Well, I try my best.
You do a fantastic job.
Thank you.
It's funny, most people probably don't even think twice about tailings dams. They're kind of like the silent giants of the mining world, hidden away in remote locations.
Out of sight, out of mind.
Exactly. But the truth is, they're everywhere, and they play a vital role in our modern lives. So for anyone out there who's picturing a bunch of beavers hard at work, let's clear up what we're actually talking about, Livia. What exactly is a tailings dam?
Well, that's a great question, Ethan, because these structures are way more complex than they might seem at first glance. After you extract valuable ore from a mine, what you're left with is a massive amount of leftover rock, often ground down into a very fine powder. That's what we call tailings.
Okay.
And these tailings are mixed with water to create what we call a slurry, which is then transported to a specifically engineered dam. Now, unlike water storage dams, which are designed to hold on to that, clean water tailings dams are all about safely containing these leftover materials, often considered a waste product.
Waste product, huh? It makes it sound like they're just a necessary evil, like just the cost of doing business.
Right.
I'm curious, is there any potential value in these tailings themselves? Could they be more than just waste?
That's a fantastic question, Ethan, and one that researchers are increasingly exploring. But before we get ahead of ourselves, let's go back in time for a bit and understand how these massive structures came to be. Where did tailings dams come from?
Let's do it.
Okay, well, in South Africa, the story really begins with the gold rush of the 1800s. Back then, the methods were incredibly basic. Picture low-bund walls, all built by hand, slowly containing the tailings.
Wow.
This upstream construction method, where each new wall is built on top of previously deposited tailings, became the standard in South Africa due to the climate and minimal seismic activity.
It's fascinating that something so seemingly simple dominated for so long, especially considering the somewhat controversial reputation upstream construction has these days. Why is that? Is it just because the method is old?
It's more about the evolving understanding of the risks involved as these structures grew larger and taller. Building on top of tailings that haven't fully settled and consolidated can compromise the stability of the dam. Think of it like building a house on a foundation of jelly. Not the most secure approach, right?
Definitely not a recipe for a stable structure. So how did we go from those early bund walls to the more complex tailings dams we see today? What are the other construction methods out there?
Well, over time, engineers developed alternative methods, each with its own pros and cons. One is downstream construction, where you build the wall further and further out, moving away from the tailings. It's like building on solid bedrock, creating a much more stable foundation.
I see.
Then there's centerline construction, which is kind of a hybrid approach. It combines elements of both upstream and downstream methods. The wall is built upwards, but also expands outwards, offering a balance between cost and stability.
Okay, I'm starting to get a sense of the different approaches, but why would you choose one method over another? What factors go into that decision?
Well, safety is always the top priority, of course. That's where the concept of the zone of influence comes in. Imagine a worst-case scenario, a dam failure. The zone of influence maps out the area that could be affected by the released tailings. Based on this, each dam gets a safety classification: low, medium, or high hazard.
So it's like a risk assessment determining how much attention and careful monitoring is needed to prevent a potential disaster.
Precisely.
But what about the construction itself? Are there any cool innovations or new techniques being developed? I mean, we've come a long way from those hand-built bund walls, haven't we?
Absolutely. Engineers are always looking for ways to improve safety and efficiency. Take spigotting, for example. This technique uses multiple controlled outlets to carefully deposit the tailings, encouraging the coarser particles to settle first, creating a more stable structure.
So it's all about strategically layering the tailings to create a stronger and more predictable foundation.
Exactly. And then there's also cycloning, where the tailings are spun in this giant centrifuge to separate the coarse material from the fines. The coarse tailings are then used to build a stronger outer wall, while the finer material goes into the center of the dam.
It's amazing how much thought and engineering goes into these structures that most people never even see. But it makes sense considering the potential consequences if something goes wrong.
You're absolutely right, Ethan. And it's not just the construction methods that matter. Water management also plays a crucial role in the safety and that ability of tailings dams, particularly in a water-scarce country like South Africa.
That's a great point, Olivia. After all these tailings come mixed with a lot of water, how do engineers manage that water and ensure it doesn't pose a risk to the surrounding environment?
That's a critical aspect of tailings dam management, and one we'll delve into in much more detail in the next part of our deep dive. We'll uncover the different descanting systems used to remove excess water from the dam, and we'll discuss the challenges of keeping potentially polluted water separate from clean water sources.
This is all so much more complex than I ever imagined. Tailings dams are truly hidden giants with a fascinating story to tell.
They are indeed, Ethan, and that story is still being written. Welcome back to the Tailings Podcast.
I'm still processing everything we've learned about tailings dams so far. It's amazing how much engineering and ingenuity goes into these structures that most people never even give a second thought to.
It really highlights the critical role geotechnical engineering plays in ensuring the safety and sustainability of mining operations worldwide.
Absolutely. You mentioned earlier that South Africa has a long history with tailings dams dating back to the gold rush of the 1800s. Let's dig into that history a bit more. What were some of the early methods used to build these structures?
Okay, so picture this. The gold rush is in full swing, and miners are extracting vast amounts of ore, leaving behind mountains of waste rock.
Yeah.
They had to figure out a way to manage these tailings, and in those early days, it was all about practicality and making do with what they had.
So no fancy equipment or sophisticated techniques back then.
Not quite. They relied heavily on manual labor and what we now call upstream construction. Imagine teams of workers building low-bund walls, often by hand, to contain the tailings. As the tailings pile drew, they'd build another wall on top of the settled material, creating a series of steps leading upwards.
It sounds incredibly labor-intensive. Are there any major drawbacks to this method?
Well, as you can imagine, building on top of tailings that haven't fully settled and consolidated can lead to instability. You're essentially building a structure on a foundation that could shift or even collapse under pressure.
So it's like building a house on a foundation of sand, or maybe even quicksand. Not the most reassuring thought.
Exactly. And as the demand for minerals increased and tailings dams grew larger and taller, the risks associated with upstream construction became more apparent. We started to see more instances of dam failures, some with devastating consequences.
That's a sobering thought. So if upstream construction is no longer considered the safest approach, what alternatives are there?
Over time, engineers developed alternative construction methods such as downstream and centerline construction, which we touched on earlier. These methods focus on building the dam wall away from the tailings using stronger and more stable materials like compacted earth or rock fill.
So it's a trade-off. More expensive construction for increased safety. But wouldn't those costs be justified in the long run, considering the potential consequences of a dam failure?
Absolutely. Investing in robust construction methods and rigorous safety protocols is essential to prevent catastrophic incidents. The cost of a dam failure, both in terms of human life and environmental damage, is simply too high.
That makes perfect sense. But even with these more advanced construction methods, there's still the issue of water management, right? You can't just let that water sit there in the dam indefinitely.
You're absolutely right, Ethan. Water management is a critical aspect of tailings dam design and operation, especially in a water-scarce country like South Africa. We need to carefully control the water levels within the dam to prevent overtopping, minimize seepage, and reduce the risk of liquefaction.
Liquefaction, that sounds a bit ominous. Can you explain what that is and why it's such a concern?
Sure. Imagine you're shaking a container of wet sand. Suddenly, the sand loses its solidity and starts to behave like a liquid. That's essentially what can happen to tailings in an earthquake. Or if the water pressure within the dam gets too high, the tailings can lose their strength and flow like a liquid, potentially leading to a catastrophic dam failure.
Wow, that's a terrifying thought. So how do engineers prevent that from happening?
Well, they use a combination of strategies, including carefully monitoring water levels, installing drainage systems to remove excess water, and using construction techniques that promote the densification and consolidation of the tailings.
It sounds like a delicate balancing act requiring constant vigilance and a deep understanding of the complex forces at play within a tailings dam.
You're right, Ethan. It's a multifaceted challenge that demands a holistic approach, considering not just the technical aspects, but also the environmental and social impacts.
Speaking of environmental impacts, you hinted earlier that tailings might not always be just a waste product. Can you elaborate on that? Is there a possibility that these materials could be repurposed or even considered a resource?
Yeah, it's an exciting area of research and development. Traditionally, tailings have been seen as a liability, something to be contained and managed at a cost. But there's growing interest in exploring the potential for resource recovery from tailings.
So it's like mining the tailings themselves. What kind of resources could potentially be recovered?
In some cases, tailings still contain valuable minerals that weren't recovered during the initial processing. With advances in technology, it's becoming increasingly feasible to extract these minerals economically, essentially giving them a second life.
That's amazing. So instead of being just a waste product, tailings could actually become a source of valuable materials. Are there any other potential uses for tailings besides mineral recovery?
Absolutely. Some tailings can be used in construction materials such as cement or bricks. Others can be used for land reclamation, filling in old mine sites, or creating new land for development. There's even research being done on using tailings to create artificial reefs, providing habitats for marine life.
Wow, those are some incredible possibilities. It's like turning trash into treasure. It sounds like the future of tailings dams could be much more than just containment and management.
It's a future where tailings dams are seen as potential resource hubs, contributing to a more circular and sustainable economy.
That's a vision I can definitely get behind. It's inspiring to see how challenges can spark innovation and lead to new possibilities.
Absolutely. And it's a testament to the ingenuity and dedication of the engineers and scientists who are constantly pushing the boundaries of what's possible in tailings management.
Well, Olivia, I'm blown away by everything we've learned so far. It's clear that tailings dams are far more complex and fascinating than most people realize. They're not just silent giants lurking in the background, but integral parts of our industrial landscape with the potential to play an even greater role in a sustainable future.
I couldn't agree more, Ethan. And as we move forward, it's crucial that we continue to share knowledge, promote innovation, and prioritize safety and sustainability in every aspect of tailings management.
Well said, Olivia. And on that note, I think it's time to shift our focus to the present and explore the current state of tailings dam design and construction. What innovations and advancements are shaping the industry today, and what challenges still lie ahead? We'll dive into those questions in the final part of our deep dive. Welcome back to the Tailings Podcast. We've explored the history of tailings dams and delved into the challenges of managing those mountains of leftover rock. Now let's turn our attention to the present and explore how engineers are designing and building these structures in the 21st century, Olivia. What innovations and advancements are shaping the industry today?
Well, it's an exciting time to be in this field, Ethan. We're seeing a convergence of new technologies, evolving regulations, and a growing awareness of the need for sustainable practices. It's really pushing engineers to think differently about tailings dams, not just as containment structures, but as integral parts of a responsible mining cycle.
We talked earlier about the different construction methods upstream, downstream, and centerline. Are those still the primary approaches, or are there entirely new methods on the horizon?
Those traditional methods are still relevant, but we're seeing a definite shift towards downstream and centerline constructions due to their inherent safety advantages. And engineers are constantly refining these methods, incorporating new materials and techniques to enhance stability and reduce environmental impact.
Can you give us some examples of those innovations? What are some of the cutting-edge materials and techniques being used in modern tailings dam construction?
One area of innovation is the use of geosynthetics, which are essentially height-strength fabrics or grids made from synthetic polymers. These materials can be incorporated into the dam walls to reinforce the structure, prevent erosion, and reduce seepage. They're like adding a layer of armor to the dam, making it more resilient to the stresses and strains of holding back vast amounts of tailings.
So it's like adding a safety net, not just relying on the compacted earth or rock fill alone. Are there other areas where technology is playing a role in making these structures safer and more efficient?
Absolutely. We're seeing the increasing use of sensors and monitoring systems that provide real-time data on the dam's performance. These sensors can measure things like water levels, pore pressure within the tailings, and even tiny movements in the dam structure.
It's like giving the dam a nervous system, allowing engineers to detect potential problems before they escalate.
That's a great analogy, Ethan. This constant stream of data allows for proactive decision-making, enabling engineers to adjust operations, implement mitigation measures, and ultimately prevent catastrophic incidents.
It sounds like data analysis and predictive modeling are becoming increasingly important tools for tailings dam engineers.
Absolutely. We're even seeing the emergence of artificial intelligence and machine learning algorithms that can analyze this data and identify patterns that might not be apparent to the human eye. This allows for more efficient monitoring, quicker response times, and ultimately a higher level of safety.
This is all incredibly impressive, Olivia. It sounds like the field of tailings dam design and management is undergoing a technological revolution. But with all this innovation, what challenges still lie ahead?
Despite all these advancements, we can't become complacent. The inherent risks associated with tailings dams haven't disappeared. We need to continue pushing the boundaries of knowledge, developing even more robust design and monitoring techniques, and fostering a culture of continuous improvement within the industry.
So it's not just about building bigger and better dams, but also about developing a deeper understanding of tailings behavior, refining our predictive models, and ensuring that safety remains the top priority.
Exactly. We also need to consider the long-term implications of tailings dams. These structures can remain in place for decades, even centuries long after mining operations have ceased. We need to develop strategies for the closure and reclamation of these sites, minimizing their environmental footprint and ensuring the safety of surrounding communities for generations to come.
That brings up another important aspect, the social impact of tailings dams. How are mining companies engaging with local communities to address concerns and ensure that these structures are perceived as assets rather than liabilities?
Community engagement is becoming increasingly important in the mining industry. Companies are recognizing that they need to be transparent about their operations, address concerns proactively, and involve local communities in decision-making processes. This includes sharing information about tailings, dam design, construction, and monitoring, as well as developing plans for long-term site management.
It sounds like a shift towards a more holistic approach, considering not just the technical aspects of tailings dams, but also their social and environmental impacts.
Exactly. Responsible mining in the 21st century requires a multifaceted approach, balancing economic development with environmental stewardship and social responsibility.
Well, Olivia, I have to say this has been an eye-opening journey into the world of tailings dams. I started this conversation with a vague image of beavers building dams in a forest, and now I'm blown away by the complexity, innovation, and sheer scale of these structures.
It's been a pleasure sharing my insights, Ethan. It's a field that often gets overlooked, but as you've discovered, it's filled with fascinating challenges and incredible feats of engineering.
And let's not forget the vision and dedication of Mohammed Sabi, whose passion for knowledge sharing inspired this podcast.
Absolutely, Mohammed's commitment to pushing the boundaries of innovation and promoting sustainability in the tailings industry is truly commendable.
To our listeners, we encourage you to continue exploring this fascinating field. Check out the show notes for further reading and subscribe to the Tailings Podcast for more insightful conversations. Because remember, knowledge is power, and understanding tailings dams is crucial to building a safer, more sustainable future for all. Until next time, stay curious.